Briefly, we're going to take a look at exponential functions here and what they look like on a graph. Generally, though, as far as an exponential function, what is it that determines or distinguishes an exponential function from another, perhaps a linear function? One of the main characteristics is that not only does it have a curve to it, but that one of the variables that are in the function itself is actually serving or acting as an exponent. So if we took a look here at the function y equals 3 to the x power, the constant is 3 and our two variables are x and y. X actually serving as an exponent. Let's make a graph here quickly, but before we actually plot the graph, let's determine some ordered pair points that will actually work for this particular function. Let's start here. Now let's get rid of that and get our ordered pair here. Let's start with x as a 0. When x is 0, what's y going to be? Well, what is any number to the 0 power going to be? It's going to be 1. So if x is 0, 3 to the 0 power is 1, therefore y equals 1. Let's go ahead and stick in a 1 for an x. What is 3 to the first power? 3 to the first power is 3. So when x is 1, y is 3. Let's do another point. Let's do x equal to 2. When x equals 2, 3 to the second power means 3 times 3. What's 3 times 3? It's 9. So when x is 2, y is 9. Well, let's take a look at x being a negative number. What if x is a minus 1? Well, if x is a minus 1, 3 to the minus 1 is the same thing as 1 over 3 to the first. And that is just simply 1/3. And we'll do just one more here. What if x is a minus 2? 3 to the minus 2 power is the same thing as 1 divided by 3 to the positive 2 power. That gives us a 1/9. Let's go ahead and plot these on a graph here and let's see if we can determine visually what's going on. Our first point is 0, 1. We start at our origin. X is 0, y is 1. Our second point, x is 1, y is 3. And we plot that one. Our next is x is 2, y is 9. Over 2, 3, 4, 5, 6, 7, 8, 9. Our fourth point, x is minus 1, y is positive 1/3. So that's somewhere in there. Our next one, x is minus 2, y is positive 1/9, and so on. If you take a look here, you can see that this is not a straight line. It's actually a curve. And I'm just going to freehand my curve here. It would look something like that. And what's going on here, as x gets bigger, y gets bigger very quickly. That's because x is serving as an exponent. On the left side of our origin, where x's are into our negatives, as x gets smaller, y's get smaller much more greatly very quickly. And that's shown here by this line here. It'll approach 0, but it'll never equal 0. And that's because there is no number to any power that'll equal 0. It'll always equal a little bit more than 0. So this line here of the curve, this point of the curve here, will approach the axis, the x-axis, and will approach 0, but it never will reach 0. Therefore, there is no x-intercept. This graph here will never intercept the x-axis. The y-intercept, on the other hand, is 1. Exponential functions can also decrease quickly. Here's an example where from left to right it increases very quickly, but you could have also had, and I'm not going to determine an equation here, but you could also have an exponential function that decreases very quickly as well. So once again, what is an exponential function? It's simply a function in which one of the variables is acting as an exponent. And then an exponential function has the following format, that y equals a times b to the x. And in the example that we looked at on the preceding screen, where y equals 3 to the x, the a there is simply 1. 1 times 3 to the x is simply just 3 to the x, because anything times 1 is itself. So that is just a quick overview of exponential functions and what they look like graphed.